Okay, these are the problems 4 through 10 from the Isosceles Triangles worksheet. I'm going to be working through these kind of step by step. Here's number 4. In isosceles triangle ABC, AB is equal to BC. It says which statement will always be true. I'm going to draw my isosceles triangle, ABC. They say AB is congruent or equal in length to BC. An isosceles triangle has two equal sides, and therefore it has two equal angles that are opposite the congruent sides. So I'm labeling those now. So I know angle A has to be congruent to angle C, choice 3. That happened to be one of Regent's multiple choice question that is pretty easy. All right, number 5. In an isosceles triangle, the measure of the vertex angle is 30 degrees more than the measure of one of the base angles. It says find the measure of each angle of the triangle. So I have my isosceles triangle. I'm going to call these guys the base angles. The vertex is 30 more than the measure of one of the base angles. So I'm going to call one of the base angles x, which, since it's an isosceles triangle, means the other one is x. And the vertex angle, the odd man out, is 30 degrees more than one of the bases, which translates to x plus 30. So now I have the three angles of the triangle represented as algebraic expressions. I can take those guys and add those measures up. They sum to 180 because they're the angles of a triangle. So now we have x plus x is 3x plus 30 equals 180. Subtract 30 on both sides. 3x equals 150. Divide by 3. And so x is 50. X being 50, we have to go back to what the question asks, which said find the measure of each angle. So x does represent an angle. It represents one of the base angles. So each of the base angles are 50 apiece. And the vertex angle is 50 plus, that doesn't look like a 50, 50 plus 30, which is 80. So the other angle is 80 degrees. Number 6 says the measure of a base angle of an isosceles triangle is 8 less than triple the vertex angle this time. Find the measure of the largest angle of the triangle. So, have my isosceles triangle again. I have two base angles and the vertex. But this time it says the measure of the base angle is 8 less than triple the vertex angle. The vertex angle is coming at the end of the sentence. I will call that x. The base angles, one of the base angles, the measurement is 8 less than triple x. That translates to 3x minus 8. And it translates to 3x minus 8 here. And so now we have a very similar situation to the last problem. We can sum up the measures of the angles, excuse me. We can sum the measures of the angles to 180. Combining like terms, we get 3x plus x, which is 7x, minus 8 minus 8 is negative 16, which is a fraction of 16 equals 180. I'm going to add 16 to both sides, and we get 7x equals 196. Divide by 7, and x is 28. Since x is 28, they want us to find the measure of the largest angle of the triangle. Well, that makes the vertex angle 28 degrees. It would make the base angles each 3 times 28 minus 8. 3 times 28 is 84. 84 minus 8 is 78. Oh, sorry. Sorry, 76. And so 76 is larger than 28, and both of the base angles are 76, and that's the answer Just as a quick check, you might want to take 28, 76, and 76 and add them, just to make sure you get 180. So 8 plus 6 is 14, plus 6 is 20. 2 plus 2 is 4, plus 7 is 11, plus 7 is 18. It checks out. So the answer is 76. Number 7, it says triangle ABC is isosceles. So here's our isosceles triangle again. But this time they told you angle A was congruent to angle B. Now right off the bat, I'm saying, well, this is an isosceles triangle. I know that the sides opposite the congruent angles are congruent to each other. So I mark those in immediately. AC is congruent to BC. So I have AB. They told us an algebraic expression for AB was 9x minus 1. BC was 5x minus 0.5. And AC was 4x plus 1. Now notice I did not give you the angles here. That's different than the last two questions. What was given to you are side lengths or representations of them. So we cannot add up the sides of a triangle and get 180 degrees. We can only add angles of a triangle to get 180 degrees. But notice these dashes that we drew in represent the fact that AC and BC are the same length. So their representations are really equal to each other. So we can take 4x plus 1 and set it equal to 5x minus 0.5. Notice that 9x minus 1 didn't really play a role yet. And we can solve this linear equation. Subtract 4x on both sides. You would get 1 equals 1x minus 0.5. Add 0.5 to both sides. And so I get x, or 1x, equals 1.5. They asked us to find AB. Well, luckily, we know AB was 9x minus 1, and now we can evaluate this expression when x is 1.5. So we substitute 1.5 in for x. 9 times 1.5 is 13.5 minus 1, and that makes AB equal to 12.5. Number 8, in the accompanying diagram, it says triangles ABC and ABD are both isosceles. They give us the measures of angles CAB and BDA to be 50 and 55, and they put this in the diagram for us. And I just made the diagram a little bigger because this one gets a little messy. If AB is congruent to AC and AB is congruent to BD, they want the measure of angle CBD. I'm going to start with this piece of information. AB congruent to AC. And I'm going to notice, well, obviously that makes triangle ABC isosceles as was promised in the problem. So I'm going to work with this triangle first. I'm going to go, well, this is isosceles. I have my two equal sides. And opposite those sides, I will find two equal angles. I can get those angles. Okay? Notice I haven't even really looked at what the question's asking for because there's something simple that we can do here. So I can get these angles, they're equal. I can get them by saying, well, they're 180 degrees in a full triangle. I know 50 of them. So 180 minus 50 is 130. Of the 130 that's left, it's getting split amongst two equal angles. So I'll divide by 2, and that's 65. So yay, both of those angles that we swooshed off before, 65. Now they also told us AB was congruent to BD. So AB and BD are congruent. Notice I only used one marking because AB already had one marking on it. Now look, that is in its own triangle down here, which is also isosceles, which therefore, across on the equal sides, you will find equal angles. Now what might be different here is I'm swooshing them off with two swooshes because I'm not at all convinced that those angles are going to be equal to the ones with one swoosh. In fact, angle D here is 55. That does not agree with angle C or angle CBA. So two swooshes are appropriate, even though they're across from sides that were equal to the ones in the green triangle. All right, so now I know from here that angle BAD is congruent to angle D, and D is 55, so that makes that angle 55. And now I can go get the other missing angle of the triangle, which I'll put 3 swooshes on, since it's different than all of the other angles that we have swooshed. So I will add up 55 and 55 to make 110. And then 180 minus 110 is 70. That's 70 degrees. So now I have all the little angles in this picture, and they are asking us to find angle CBD. So now we just have to apply the picture and look at what we have going on here. Angle CBD is this wide, big fat angle here. And so what we can do is add up those two little angles that make it up. So measure of angle CBD is equal to 65 plus 70, which is 135. And that's our final answer. I really like that problem. I think if you really understand what's going on with this topic, that's a good problem. And if you don't, it's a bit troublesome. Number 9 says, Gus says if a triangle is an obtuse triangle, then it cannot also be an isosceles triangle. Is Gus correct? Well, Gus is not correct. And I'm going to just kind of draw a little picture here to explain why. So imagine if I had a really big fat angle here and two equal sides. Well, now you have an isosceles triangle that is obtuse. In fact, I'll make up nice numbers. Let's pretend this angle up here is 100 degrees. And the triangle is isosceles, so across from your equal sides, you will find equal angles. I can go find those angles now. Let's make this neater. Make that, say, 100. Well, how can I do that? Well, all the angles of a triangle add up to 180 degrees. So I'll have 180 minus the 100 we already know about, which is 80. 80 divided by 2, which is 40. So here is an example of a triangle that is both obtuse and isosceles. So Gus is incorrect. He is incorrect because a triangle can be both obtuse and isosceles. For example, and I'll actually label this as triangle ABC. Triangle ABC is obtuse since the measure of angle B is 100, which is greater than 90, and angle A is congruent to angle C, making triangle ABC isosceles. So now you explain, this is what in math we call a counterexample. It's an example of why Gus is wrong. It's countering his argument. It goes against his argument. Think of the word counterclockwise. That means going against the way the clock goes. So this is called a counterexample. When Gus makes this outrageous claim that an isosceles triangle can't be obtuse or vice versa, here is our example to counter him. So we call it a counterexample. All right, and one more thing, number 10. This question is one that kind of popped up on the Regents a couple of times, something like this. So it's an important one to understand. In the diagram below, it says LO is congruent to LM. Well, that automatically makes that side triangle isosceles. So right off the bat, I'm going to label this triangle, march across, and find the congruent angles. And there they are. They told us angle L was 50. Well, angle L lives in that triangle, that isosceles triangle. And they also tell us NOM, angle NOM is 28. Angle NOM goes in the mouth right here, little guy 28. And they want us to find the measure of angle N. So obviously we have some work to do. But if I take a look at the isosceles triangle, which is right here, I can get the base angles. They're 180 degrees in a triangle. Whoops, sorry. They're 180 degrees in a triangle, 50 of which are accounted for. So that's 130 left over. Since the angles are equal, we'll divide by 2, and each of those angles is 65. So this angle is 65, and that's 65. Now, in order to find angle n, we really need to get into the side, the rightmost triangle, which we can get into right here. We see this point, and we look at this angle, and its adjacent angle forming a line together. Those are called a linear pair. So to get this angle right here, we can do 180 minus 65, which is 115. So now I have a triangle on the side here. This triangle right here, which we know 2 of the angle measurements, and we can get the third. So I can take 28 and add it to 115 to get 143. And 180 minus 143 will be left over for angle n, which is 37. And this is the measure of angle n. So n is 37 degrees. And that's it.